Hello, and welcome to this AWS webinar on Accelerate Productivity by Computing at the Edge. My name is Ian Perez-Ponce. I'm a Senior Business Development Manager here at AWS. To set the stage for today, we've identified a few learning objectives to help keep us on track. They may seem a bit out of order, but bear with me on the approach. First, we'll dive into some of the challenges that have led to the advent of edge compute and why pre-processing or processing data at the source has its advantages. Next, we'll go over a few representative customer use cases along with common workload characteristics that exemplify these benefits. And lastly, we'll shift to how AWS Snowball Edge with Greengrass can provide a viable platform to extend cloud-native services to the edge for various use cases. Let's start with a look at some of the main drivers behind computing at the edge. If we take a step back and look at the breadth of services AWS offers for data migration, data lake storage, analytics, and artificial intelligence, machine learning powered insights, it's very easy to ask the question, why? Why would anyone want to attempt to process or analyze data at the edge when you have the full Monty of services neatly packaged and available in the cloud? While neither approach is mutually exclusive, the answer often depends on the circumstances and overall objectives. One could argue 100% of data storage and processing in the cloud is perfectly viable until it no longer is. When certain environmental conditions emerge, we can begin to question the value of centralized data processing in the cloud versus at the edge. At AWS, we've classified some of the more common environmental conditions or constraints as laws. First, the law of physics, also known as the speed of light challenges. Take the example of safety-critical control in a factory where an emergency stop operation should result in the manufacturing line or robots to stop instantaneously. Or physically remote environments, such as mining facilities or deep oil well rigs where intermittent connectivity is expected. Next is the law of economics. In many industries, data production has grown much more quickly, and the cost of bandwidth is not falling as fast as the cost of storage and compute. Local aggregation and filtering of data allows customers to act on raw data locally and then upload only the high-value data to the cloud for analytics and storage archival across all site-specific data sets. Last is the law of the land. When dealing with privacy, regulatory, and compliance requirements, which often curb the ability to transfer data, even when network capacity is plentiful. Some governments impose data sovereignty restrictions on where data may be stored and processed. Medical data, for example, might need to be stored on site at a hospital for years, even though it is also stored in the cloud. And so regardless of what type of data is being generated at the edge, we realize that accelerating time to value in a cost-efficient and compliant-sensitive manner means extending AWS native services beyond the cloud perimeter. Because there are times when relying on a constant connection to the cloud isn't desirable, efficient, or even feasible, AWS offers a blend of IoT, compute, and storage services that can operate at the edge, so latency and data sovereignty is never a concern. Or, if sending all the data to the cloud is cost prohibitive because of recurring bandwidth costs, AWS also provides the ability to transfer that data offline safely and securely. AWS Snowball Edge with Greengrass is a hybrid solution that extends cloud-native capabilities to your applications and devices living at the edge so that they can act locally on the data they generate while still taking advantage of a broader set of services in the cloud. It's worth making the distinction here that processing data at the edge does not preclude more sophisticated processing or analytical workflows from being performed in the cloud. In some cases, 100% localized processing may be sufficient, resulting in only data archival in the cloud. In other cases, first-pass processing at the edge will produce sanitized data sets that can be further mined for valuable insights once that data lands in the cloud. More specific to IoT environments, one needs services that can provide for localized actions, keep device data in sync, and securely communicate with other local devices, even when not connected to the cloud. That's where AWS Greengrass comes in. Once a cloud connection is reestablished, both device data and state needs to be synchronized automatically. Alternatively, data sets can be locally aggregated and processed in real time, and finally, imported into Amazon S3 or Glacier using Snowball Edge. It's worth noting that AWS Greengrass can also run on a mix of hardware from standard IoT gateways to Raspberry Pis if there's a desire to decouple edge functions or have more complex topologies in play. Now that we've established some basic fundamentals around the value of edge computing, let's look at some use case examples. While this is by no means a comprehensive list, we acknowledge there's broad interest and adoption in industries ranging from academic research to transportation. The common thread here, regardless of industry, is a specialized application environment that exists beyond the boundaries of a conventional data center and more often than not involves decentralized generation of data where data volumes are significant, often approaching petabyte scale, and broadband network connectivity is inaccessible or intermittent. The Hatfield Marine Science Center at Oregon State University is a perfect example of an academic research use case. OSU is in the business of supporting environmental and ocean ecosystem research. Their workload requires collecting and analyzing coastal and oceanic imagery at a rate of roughly 60 terabytes per week. Using Snowball Edge with Greengrass and Lambda, OSU was able to effectively store and process data at the edge with quicker turnaround times and less overhead. What used to take weeks or months for their data processing workloads was reduced to days by providing an agile and ad hoc computing solution. In the industrial IoT space, General Electric's oil and gas division was initially able to leverage Snowball for cost-effective storage migration for its pipeline inspection devices, while paving the way for localized processing of that data with Snowball Edge. While these inspection devices may not number in the thousands like other commercial IoT deployments, the amount of sensor data generated can be significant over the span of thousands of kilometers of pipeline in often hard-to-reach areas. In the healthcare sector, Philips has been at the forefront of modernizing administration of their on-prem medical instruments such as imaging and MRI machines by taking advantage of edge computing capabilities in Snowball Edge. For their use case, Snowball Edge is able to provide durable object storage together with real-time processing capabilities for their Health Suite applications across distributed healthcare facilities. Having access to storage and processing during periods of connected and disconnected states helps Philips and its clients mitigate against potential disruptions that can affect the quality of patient care. In the transportation and automotive sector, we're starting to see significant momentum for edge computing in use cases where autonomous vehicle technology and/or advanced driver application systems are being developed. Several manufacturers and suppliers in this space are growing their R&D fleets at global scale with volume and complexity of data growing even faster. To cope with the exponential increase in data, to the tune of double-digit petabytes for some, Snowball Edge with Greengrass is being evaluated for deployment in regional smart garages and maintenance facilities where vehicle trip data can be easily offloaded, stored, processed to produce immediate and actionable insights without having to incur hefty private line fees or endure unnecessary round trip times to the cloud and back. Now that we've reviewed some real-world use cases for edge compute, let's dive a bit deeper into enabling services starting with Snowball Edge. We start by asking the question, what is Snowball or Snowball Edge, and how do they differ? Over the years, both we and our customers have learned that moving large volumes of data over the internet can be costly in terms of time and expense. Shipping purpose-built devices such as Snowball without having to purchase the hardware virtually eliminates the friction with large-scale data ingest. As mentioned earlier, the cloud or remote access to may not always be accessible or practical, especially for locations where network connectivity is limited or intermittent. Ruggedized devices such as Snowball Edge can provide both durable storage and processing capabilities to offset the exclusion from ubiquitous network access. Where several have relied or continue to rely on using conventional hard disk drives or solid-state disk drives for data capture and ingest to the cloud, we found that shipping hundreds or thousands of these back and forth to accomplish data migration to the cloud is highly error-prone. One of the simpler yet more impactful features of Snowball and Snowball Edge is the automated logistics handling built into each device that makes sending one or several units in parallel a scalable process. The Snow family of devices comes in 3 flavors: Snowball, Snowball Edge, and Snowmobile. Where Snowball and Snowmobile are focused on pure data transfer as a core competency, Snowball Edge takes a departure from the conventional data shuttle approach by providing flexible compute and durable storage options for on-prem deployment. Of the specifications for Snowball Edge, I'd like to call out the CPU memory footprint, which is equivalent to an M4 4x large instance for those of you familiar with our EC2 service, as well as the expansion of connectivity options now including 25 and 40 gig E. As shown in the illustration, it's also worth noting that multiple Snowball Edge devices can be clustered together to achieve scale across both storage and compute dimensions. To recap, these are the key features that distinguish Snowball Edge from the regular Snowball appliance. An S3 compatible endpoint that's built in, the ability to run AWS Greengrass and associated Lambda functions, a file interface that supports NFS shares, faster data transfer speeds, the ability to cluster for both storage and compute, and hardware-enabled data encryption. Reinforcing the point that I made earlier around support for Greengrass and Snowball Edge, we'd like to make sure everyone understands that Snowball Edge is not built for data migration alone. Lambda functions can be created and exported to Snowball Edge to accommodate a wide array of data processing use cases. The main event trigger for Lambda functions on Snowball Edge is S3, so that when files or objects are written to a specific bucket on the device, the associated Lambda function will be invoked based on the associated S3 put operation. So what are some of the Lambda function examples for data processing, pre-processing at the edge? We talked about industry-specific edge compute examples earlier at a high level, but from a Lambda perspective, here's a typical workflow example where media content such as images and or videos can be uploaded to Snowball Edge and then indexed and transformed, for example, resized prior to import. Resizing content files beforehand may enhance subsequent analytical processing pipelines once the data lands in your S3 account, while achieving cost savings over running the same functions in the regular Lambda service. Another example typical of IoT environments is taking time series data from variable sources at the edge, indexing that data, and then performing some lightweight transformation such as CSV to JSON file conversion in order to support a richer set of processing pipelines after the data is imported into Amazon S3 and Athena, as you see in the example here. Lastly, let's go through an accelerated workflow of how to order and set up a Snowball Edge. We won't have enough time to dive deep into the mechanics of Lambda or Greengrass configuration today, but I at least want you to learn the fundamentals of provisioning a Snowball Edge job and what to expect in case you're eager to experiment with the service after this webinar. The process of ordering a Snowball device is pretty straightforward. The job request workflow is initiated from the AWS Management Console and involves 4 basic steps. First, job creation, which we'll walk through in a few. Second, local setup and connection of the Snowball device once it arrives at your site. Third, any data transfer and or processing on the device while deployed remotely. And fourth, importing the data into your S3 account after the device is returned to AWS. There are some slight nuances depending on the job type you've selected, but for brevity's sake, these are the most basic steps, functions you'll observe. During job creation, you'll be presented with 3 different job profiles. First is import into Amazon S3. The second job profile is exporting from Amazon S3. And the last one is local compute and storage only. Options 1 and 2 are pretty self-explanatory, while option 3 implies that we intend to order a cluster of Snowball Edge devices for durable storage and compute deployment. For the purposes of this demonstration, we'll go with option 1, import. Next, we'll provide basic shipping information and the carrier service level option, which is typically 1 or 2 day service. After that, we'll specify the device type, which I've chosen as Snowball Edge. Under storage, you'll notice I've specified 3 S3 buckets, which I want to be created on the device. These can be new or existing S3 buckets in your main AWS account. After specifying the S3 buckets, I can opt to configure compute parameters which actually correspond to Greengrass and Lambda being configured on the device. Here I'm specifying a simple Lambda function and version number that will be invoked every time a file or object is uploaded to the associated bucket. Note that each bucket can only have 1 Lambda function associated with it. However, up to 7 Lambda functions can be configured per job before reaching the memory capacity limit. Additionally, Lambda functions can be updated via remote whenever there is connectivity between your Snowball Edge and your main AWS account. So don't fear any changes to your code after job provisioning. For security, each job requires that we specify an identity access management role and a KMS managed encryption key, as you see here. Notifications are then configured to alert you of changes in status for your job. Lastly, we're asked to confirm our job inputs before creating the job. Once a job is created, the dashboard will reflect changes in the status and chain of custody information until the job completes. Once the device arrives at your location, you'll perform a basic unlock operation to use the device, which requires access to the unlock code and manifest file. Both of these are accessible in the Snowball Management Console and can only be accessed by the original requester. This sample output confirms the Snowball Edge has been successfully unlocked and is ready for read-write operations. To execute read-write operations and any associated processing on the device, standard S3 CLI commands can be executed as you see in the AWS S3 ls command here. Recall that to invoke a Lambda function, any S3 put operation to a target S3 bucket would serve as a trigger for that function. To return a Snowball Edge after its use, all that's required is a simple power down of the device for return shipment. You'll notice the onboard e-ink display will automatically populate with the appropriate shipping label. That wraps up my quick walkthrough through setup and provisioning for Snowball Edge. For additional resources, including pricing and how-tos on Snowball Edge, please visit the main landing page at the URL provided below. Similarly, for AWS Lambda, you can visit the corresponding landing page at the URL provided. Lastly, I'd like to thank everyone who joined for making the time to learn about AWS Edge Computing Solutions. For those of you who are inclined to get some hands-on, I encourage you to order a Snowball Edge and begin experimenting with its features on your own. We'll now open it up for Q&A. However, feel free to reach out via email if you have any questions or feedback after we conclude.